Welcome to the parent effect. So I'm just going to go through a couple of questions using binomial distribution, just standard questions and just basically going through how we apply the formula that you can see here and how we pull out the information from the questions so that you can hopefully have some success with these questions. So there's essentially three unknowns in our formula here. So the first thing is your P. So the P is your probability of the question they've asked you happening. 1 minus P is going to be the probability of it not happening. Okay, so if it's 20% chance of happening, then it's 80% chance of not happening. Because remember, binomial is either it happens or it doesn't. So it's only two options, success or failure. So the two probabilities have to add to 1. The other thing that we need to know is the number of trials. So N is for the number of trials. So how many times are they trying to have this outcome? And then R is what I call the question. So what are they wanting to know? So if we look at this question, we have, I don't know why they've called it paper, stone, scissors, but paper, rock, scissors is what I would normally call it. Actually, rock, paper, scissors. And you're guessing what the other person is going to do. And you want to know the probability that you are right 5 times out of 15. So hopefully you can identify a few numbers here. 15 is the number of trials, so N is 15. 5 times is the question, so R is 5. And the probability they haven't given you, but because you're guessing and you have 3 options, we're going to take the probability as being 1/3. So in order to do this, you are going to grab your calculator and you are going to be plugging in what it says on the formula over here. Okay, so when it says NR and it's got them in those long brackets, that actually means 15CR, so R was 5. Okay, so this is actually means NCR. And then you're going to multiply it by the probability, which is 1/3, to the power of the question, which was 5, times by the probability of it not happening, which is 2/3, and that happens 10 times. So hopefully this formula makes sense because you're essentially having you guess correctly 5 times, having you guess incorrectly 10 times, and then 15C5 is working out the number of different ways you can have 5 correct answers out of 15, because you might get the first 5 right and the next 10 wrong, or it might go wrong, right, wrong, right. There is 15C5 different ways of that happening. So instead of drawing a really, really large tree, you can work out the different combinations that way. So plugging it on a calculator, you're actually going to go 15, shift C5, you're going to multiply by 1/3. You're going to go to the power of 5 times by the probability of it not happening. Whoops, probably need a bracket there. To the power of 10. And that equals 0.214. Just doing one more question here. So we've got a machine. Again, we're looking for the numbers that are important. So I've got an 80% here. We've got 8 microchips. And what's the probability 6 of them work? So just trying to work out what each of those ones are. Obviously the P is 0.8. 8 microchips is our N. And 6 is our question. So R is 6. So again, you're going to just be plugging it into this formula. So 8C6 is our NCR times by the probability of 0.8 to the power of 6 times by the probability of them not working to the power of 2. And again, you just chuck that in your calculator. 8C6 times 0.8 to the power of 6 and 0.2 to the power of 2. You'll know whether you've got it wrong if it's a number over 1. Just other things to take note of is that 6 plus 2 should always add to the total here. So if you look back here, you've got a total of 15, 5 and 10. So the little checks like that can help you from making a mistake. So hopefully that clarifies how you can input the calculation for a binomial distribution and how to pull out the correct numbers from the question. If you want more content like this, please like and subscribe.